So today we're going to start with Terraform. The question is, what is Terraform, right? We're going to get into all of that. We'll start with the introduction into what I call infrastructure as a code, which is also, you hear it says ISC, or they call it infrastructure as a code. What infrastructure as a code means, instead of going to, for example, you have AWS, and all of you know how to provision an instance from AWS, right? Instead of manually going to AWS to create an instance, what we do in this case, we write a code, and the code creates the instance for us. That's what I call infrastructure as a code. So you're creating infrastructures, you're creating resources using code instead of manually creating the infrastructures, right? So that's what we're going to do. So you've learned a little bit about AWS. There are other resources that we're going to learn in AWS, but all these resources, in other resources, you can provision them, right, using infrastructure as a code, right? You can provision your instances, the VPC that we're going to, Luis is going to teach you guys on Sunday. We're going to, those resources, we can provision, use IAM resources, EKS resources, which is Kubernetes at AWS. All those resources can be provisioned using code, infrastructure as a code, right? So a little bit of programming, but that's what we're going to learn today. It's very valuable. Every organization that you want to join wants to know if you know how to do automation. So when it comes to DevOps engineering, this is the kind of automation that it's more or less like you're required to know if you are a senior engineer, because at some point, every organization, there are some organizations that have not yet adopted infrastructure as a code, but they want to hire you if you know how to, if you know Terraform, right? If you know Terraform, and so on and so forth. So they want to hire you. The first question, do you know how to do automation, right? You hear them say that question. So this is very important, right? So let's go to the next slide. We'll get a little bit into the theory, then we'll do practical hands-on on this. So there are three approaches, right, that you can provision your resources. The first one is using graphic user interface, which is using the Terraform has something like a graphic user interface, like AWS interface, like this is an interface that, and you can just go and provision it, right? But that's not what we're going to use. It also has, you can also do it using CLI. CLI is like your mobile XTEM where we go in and provision. That's probably the method that will go. You can also use like a VS Code, right? You can use VS Code. What's VS Code? I think everybody should know what VS Code is right now. What's another name for VS Code? It's always called, there's a generic name for something like VS Code that you can use, right? There's a generic name, but you can use VS Code. There are other tools like that you can use. Mostly they're used for programming, right? You can also use that as a matter of fact, most programmers use tools like this, like VS Code, to do programming. In most cases, you will not really see people use CLI, right? But if they want to document and have a version control of their programming, they use something like VS Code to do that. You can also do that as well. So these three approaches, you can use them to provision your resources, okay? So let's get a little bit into the introduction, basics of Terraform. What is Terraform? What's the purpose of Terraform, right? Let's get a little bit, before we get into that, let's look at the architecture of Terraform, okay? So the architecture of Terraform, so this is the DevOps engineer. So this is you, right? And you want to provision an infrastructure, okay? There's a code that you have to write, right? Once you write that code, it's always called manifest. Could be a manifest file, or they call it configuration file. But in most cases, the name that they call is manifest file. I think you can call it configuration file as well. Once you write that manifest file, right, the workflows that you have, which is, we'll get into the workflow, Terraform init, Terraform validate, Terraform plan, Terraform apply. Once you apply that, right, the manifest, you have to do Terraform apply. Now it creates what's called a state file, right? This is a state file. Let's not get into the details of this. We'll look at it as we go on, but know that it creates what is called a state file. And this state file is stored as a plain text on your local machine, right? You can also create an S3 bucket where this can be stored for safety purposes, right? You don't want to store your state file in your local machine. So you can create something like an S3 bucket, which is a resource in AWS as well. but we're looking at the architecture right now. We're not getting into manifest and how to create that. We'll get back into that. So once this is done, this goes into your Terraform registry. That goes into its Terraform registry. In your Terraform registry, you have what is called providers, right? These providers are the organizations that provide these resources. Microsoft Azure, Google, GCP, AWS, MVWare, etc. Those are providers. Now, these resources, because you want to create these resources in your manifest file, you have to state the provider. Who do you want this to be your provider? Where do you want to provide these resources? So this with your once that state file is created, right? This state file is stored here. It's stored as a .ts state file, right? Now, this state file will go in and determine your registry where these resources are going to be created, right? And it's done through plugins. So you have plugins that in Terraform that links. Plugins are extensions that connects another infrastructure. So in this case, Terraform has a plugin that connects to Azure, that connects to GCP, AWS, MVWare, right? That can communicate through their APIs, right? So it has all that. So this is what it looks like. These are the providers: Azure, GCP, AWS, OpenShift, and it's as simple as that. Once that communication is established, your resources are going to be provisioned automatically, right? Once you get that code correct and you hit Terraform apply, automatically those resources will be created for you, right? So it's as simple as that. This is the architecture. It's not complicated at all. It's very simple and ridiculously easy to use. Once you master how to create the manifest, that's all you need to do. And the manifest file is written in a declarative way. Declarative way of writing a programming, I think I explained this, I don't know if it's this class, is like having a black box. You know, the black box that it's in a ship or in an aeroplane. They put that in an aeroplane that collects data, right? But you feed something into it. All you need is feed that information, and it's telling the information, give me an outcome, right? I don't want to know how you do it, but I want an outcome. I don't care how you do it. I want to have an EC2. I want to have VPC provision. I want a subnet to be provisioned. I want all that information, and that's what I need. I don't care how you do it. But then you come to this is a black box. You fit into a Terraform black box. I call it a black box now, and it spew out those resources that you wanted, right? So that's how Terraform works. Okay, right. Then we've spent enough time on the architecture. So what it is and its purpose? What is Terraform? Terraform is an open source infrastructure as a code tool developed by a company called HashiCorp, right? It enables users to define, provision, and manage infrastructure resources, right? Its primary purpose is to automate the provisioning and management of infrastructures. That is its primary purpose. So if they ask you, what do you use Terraform for? Is for automation and management of infrastructure. Right? So you can provision infrastructures automatically, and you can manage those infrastructures as well, right? In a predictable and consistent manner, such that if you have a manifest file, right, you want to create an resources, you can use the manifest over and over and over, and you can version control it, right? You can put it in the GitHub and version control it, and you can use it, write it once and use it over and over and over. So whenever you want to create an infrastructure, you use it to create. When you want to destroy the entire infrastructure, you can just destroy it without going to do a manual. So why do you really need to use this, right? Where you can just go to AWS and create one infrastructure. Okay, in what we're doing right now, teaching classes in your local environment, or you want to test an application, so you can spin one infrastructure or one instance and do your test, try your application. But in organizations, in big organizations, for example, you work for Walmart. Walmart has like 1,000 instances running, right? And they want their applications to be in all these instances that you've created. Now, sitting down to create those instances one by one is going to take you forever, right? It takes you manual provisioning of infrastructure. It's going to take you forever. You can use Terraform and create 1,000 instances at once. So that's an advantage of using Terraform, right? Key aspects of Terraform: declarative configuration. I told you about declarative configuration, whereby it's not a step-by-step approach. It's what's called declarative approach, whereby you have input 1 instance, EC2 instance to be provisioned, you want VPC to be provisioned, you just tell Terraform to do that, and it does that for you on the other side, right? So configuration is declarative. It's another aspect is infrastructure provisioning. So you can use it to provision your virtual machines, your network, your databases, load balancers, and so on and so forth. You can use this Terraform to do that. So those are some of the key aspects. I think we have all that. Okay. Another thing is multi-cloud and multi-service provider support, right? You can use this cloud agnostics, in other words. So you can use it in Azure, AWS. So it doesn't really take into consideration if it is a particular kind of cloud infrastructure, right? You can provision in Azure, you can provision in AWS. So it has ability to provision resources in multiple cloud services. Okay, and it also has what they call state management. Terraform maintains a state file. So that state file is what I was explaining. When you create a manifest file, it creates a state file for you, which is stored, and you can store that state file in your S3 bucket. If you don't store it, it's stored as a plain text on your local machine, and you can manage that state file. It has what is called modularity and reusability. It supports what we call modularity, meaning that you can create your configuration in models, right? And you can reuse these models. You create it once, and you can reuse them, right? Basically, if you know a little bit about programming like C++ languages, you can create them in models, and you can call this model from anywhere. You create it once, and you can call it to reproduce whatever you need it to reproduce or the outcome you need it to perform. Execution plan and workflow. So it has a simple workflow, which I was telling you about. If you Terraform init, Terraform plan, Terraform apply, Terraform destroy. So these are the workflow that you use to execute. Very simple. Terraform init will initialize your state file. Terraform plan you can do validate. Validate will go in and look at your configuration and make sure that there's no error, right? Then you can do Terraform plan. Terraform plan would show you all the resources that is going to be created to make sure, and you say, yes, it's okay. Then you can do Terraform apply. Once you do Terraform apply is going to create all the resources that you need to be created. Then you want to destroy the entire infrastructure that you just created. You can use Terraform destroy, and Terraform destroy is going to destroy all that. We'll get into all that on the hands-on, so you can take a look at it. Right. The primary purpose is to provide tools for managing infrastructure, automation and consistency, simplified configuration, efficient collaboration, whereby you can have version control system, and you can share this to other people. If you are in an organization, you can share it with your colleagues and all that. It's scalable. You can scale it as you can scale this infrastructure. For example, as your application increases, you can scale it up or scale down your infrastructure. You have the ability to do that. Terraform is also flexible, ease of use, and ability to manage infrastructure across various platforms, right? So any platform that you have, you can use Terraform to manage that infrastructure. You can use it to provision Kubernetes in EKS or EKS in AWS. You can use it to do a lot of things. It's very versatile, and it's not complicated at all. So this slide gets into a little bit into explaining how providers work. So who are the providers? So providers actually are the organization like AWS, like Microsoft Azure. Those are all providers, right? So this slide explains how providers actually work. Providers are plugins responsible for managing the lifecycle of a particular type of infrastructure service, such as cloud, container, orchestration, database, and so on and so forth. So provider configuration. Each infrastructure service or platform requires a corresponding provider in the Terraform. In other words, in your manifest file, you have to state who is your provider, who is going to provide these resources, right? And it has to be able to access what's called API. API are the interfaces that one tool talks to another tool, right? Those are the APIs. You create APIs. APIs are more or less like a code, but you do not really know that. You just have ability to communicate with every other tool, right, through API. It's just an interface that one tool can use to communicate with the other tool. Okay, so it also does what is called resource management. For example, AWS enables Terraform to manage resources like EC2 instances, S3 bucket, IAMs, roles, etc., etc. Okay, and it has what is called lifecycle management. So lifecycle management is the ability to create, update, modify, delete. Whenever you hear about lifecycle management, it's about from cradle to grave, from when this thing got manifested until when you destroy it, right? That's lifecycle management, managing the entire lifecycle of a resource. So it helps you do that. State management. Providers interact with Terraform state management to track the status of resources being managed. So when the first time you do Terraform init, right, it creates what is called a state file, like I explained. Right, this state file is in there. Now you can go back and change the desired state. For example, you want to change your EC2, the count or the number. You want to change it from 3 to 4. Once you change that number in your manifest file and do Terraform apply, because you have a state file that is stored, the new file that you created is going to be compared with the state file that is stored in your system. And if there's any differences, right, if there's a difference, it's going to create a new state file and replace the other one. If there's nothing is changed, it has what it called idempotence, right? It's not going to create any other thing because there's nothing to create, right? When we do this, we'll do a practical so you can take a look at it. Interaction with different infrastructure services. So cloud providers, we've talked about this already. Cloud providers offers Terraform provide that allows the creation of management of cloud resources, including computing those instances. We've talked about this. It's just a repetition. It also does what is called container orchestration. Like I told you, you can use Terraform to create EKS, which is the Kubernetes, the type of Kubernetes that you use in AWS. You can use it to create databases, MySQL, PostgreSQL, etc., etc. You can use it to create networking services, DNS services, CDN services, right? Content delivery network, that's CDN services. Custom or third-party services as well that you can create. You can also use AWS to do that as well. Declaring a Terraform provider, right? Before you, for example, before you are able to create any resources in AWS. In AWS particular, you need what is called the access key and the secret key. Right. Last time we did AWS, I think Lewis showed you how to create an access key and a secret key. So that's the first thing that you do to be able to have access, right? And I'll show you how to do that. Okay. So let me see if anyone has a question before we continue. Then we're going to get into the installation of a setup of Terraform. Anyone has a question? Let me see how many people we have here. Okay. All right. So let me ask a simple question. ID, Dion, what is Terraform? What do you understand as Terraform?
Capturing the words. So far, it's
just say what Terraform does. I mean, you don't need to explain that. How do you understand what it does?
I mean, I think it's used as a tool. It's a tool that is used to build and I believe change versions like with a script.
Okay. All right. IB, what do you understand as Terraform? What does Terraform do? Ibrahim, are you there? IB, are you there? Can you hear me?
For me?
IB.
Oh,
IB, not ID. Yes. Okay. You can't hear me. Maybe it's network problem.
Yeah, can you hear me?
Yeah, I can hear you now.
Okay. You said something about Terraform that is it can be used for automation and management of infrastructure. There's actually a broad tool that can be used in a company, and the primary purpose of it is used for automation and management of infrastructure.
Yeah, that's good. Brenda, are you able to? Do you understand what Terraform is? Can you chime in?
Yeah. Can you hear me?
Yeah, I can hear you.
Okay. I think to add to what IBI said, though I can understand that it's used for automation, and also it can be used to provision many instances, like you said. And I think for now that's what I still understand. I have other things in there.
Okay. Yeah, good. So that's what I wanted to get your understanding and make sure that everybody at least know the basic of what Terraform is useful. So, you know the way we provision EC2, right? We do it manually. Let me explain it again. We do it manually, right? For example, we want to create an instance. Now I have to go, this is launch an instance and do it manually, right? But in this case, I don't have to create this instance manually, right? I don't have to create this. I'm going to use a code and the code would create this. and I can use that code to manage this infrastructure. In other words, I'm doing automation, right? I'm not doing it manually, creating this manually, right? See all these infrastructures. These are resources in AWS. See all these resources, right? These are all resources. You have a lot of services, right? You have a lot of resources in AWS, and all these resources in AWS, you can automate the provisioning of all of them instead of coming, right, and doing it manually one by one, right? You can automate the process. So that's exactly what you use Terraform to do. Okay. So now we're going to get into installation and have a hands-on on Terraform. I have a GitHub repository. Let me see if I can pull my GitHub repository. Okay, still here. I have a GitHub repository here that I want to use. Basic of infrastructure. I have all the notes. I also have it in this GitHub repository. I was thinking it looks better on a PowerPoint. So I spent an entire week recreating a PowerPoint. I created this one, then I created another one. So I'm not sure if you do not really understand things. So I'll be using 3 of them. I'll be using all of them, right? I hope I don't confuse you, but let me show you the other PowerPoint that I created. This is another one that I created that has, this one doesn't have, because the other one has all the notes. If you want to study, I want to create something that doesn't have all the notes, right? That I can just use to explain, and actually more or less like a hands-on, right? So for example, Terraform installation, you can use the Terraform CLI. You can install it using Terraform CLI. You can also use AWS CLI. You can use VS Code Editor, right? Editor was the name I was looking for when I was saying VS Code. General name is an editor. It's not only VS Code. You have other editors as well that you can use. For example, we have another one that I showed you last time, the popular one. This is a VS Code. This is an editor rather. Bracket is an editor, right? So this Bracket is an editor as well. You can use Bracket as well to write your code. So this is an editor as well. You have various editors in the market that you can use. It's not only VS Code. VS Code is very popular because there's a lot of things that you can do with it. But there are some people that don't really like VS Code. They use other editors as well. So you can also install Terraform in you have a Mac OS. You can also use Windows OS, Linux OS. All this you can install your you can use this operating system to install your Terraform. Okay.
Is the VS Code, is it the Visual Studio Code?
That's the Video Studio Code. Yeah, so I have one here. Let me show you what it looks like. Yeah, this is a Visual Studio Code, right? Have I done anything with Visual Studio Code with you guys in this? I think I have a recording I will share with you, so you can, because when you start dealing with developers, this is what you're going to use in most cases, right? So you know the basics. I have a recording that I will share with you, right? So you can write your manifest file here in VS Code as well. Okay, this is what it looks like, right? I probably will switch back and forth on this one. Okay, so let's get into installation of Terraform real quick. So to install Terraform, we're going to install as on a Linux operating system. So I'm going to bring up let me move this out here. No, this is not even what I'm looking for. I'm looking for my mobile XTEM. But I need to create the first thing I need to do is to create, so I need this. I also need to create my operating system machine, the Linux operating system machine. So I need an EC2. I think I already have a Terraform instance running. Let me see my instances, see what I have. But we're going to install a new one so you can know how the installation is done. Right, I think I have a Terraform. Probably not. Or I have Ansible, not Terraform. I have Terraform here, right? But that's not that. Let's stop that. Let me start real quick. Maybe I can show you how it works real quick. Then we do the installation. Let me see if this one still works. Let me start this real quick. And while that is started, let me create a new instance as well. We'll call this okay. Now I want to use Ubuntu. Okay, and I want to use T2 Medium. And I have a keep I don't want to create a new one. I'll keep everything the way it is. I'll use the default VPC. Okay, then I'll launch. While I'm launching this one, this one is running already, so we can go ahead and SSH into this one. The keep is Sana. Yeah, wait a minute, it's not connecting. Let's see, was that an Ubuntu server? And what was my class 002? Class 002 is what I use as my key pair. Let's do that again. Class 002 is my key pair. Okay, now we're in. So let's clear this. Okay, I have a step file in here. Let me cd into my Terra. I think that's why I have ls into this. The directory has no Terraform configuration file, so I don't have any configuration file here. Do I have a configuration file here? I have a cd. Oh, hold on. Terra ls. I don't have any file in this. Okay. I don't know where my files are. I thought I used this previously, but there's nothing in here. Anyway. But I have Terraform in here. I've installed Terraform here. I don't have any file to initialize, so I don't have anything in here. Okay, so let's go ahead and create one so everyone knows how to set up Terraform. Let me not waste your time here. Okay, so now we have I have a new instance that's running. I call that Terraform 2. I can search my running instances, or I can use I have 2 instances running, so let's SSH into this one. Let's do a fresh install. Okay. We can install it on the other one, but I just want to use the new one. That was an Ubuntu server. And this time around, my key pair was Sona. But let's take a look at the codes real quick. Okay. So in this case here, like I said, you can use Mac operating system, or you can install it using your Linux operating system, right? If you're using a Mac operating system, this is what you need, right? You need a CLI, which is a CLI, the mobile XTM is good enough. You can use this to install on your Mac operating system, right? But what we need to do is to install it on our Linux operating system. But before we go there, we have to configure, right? We have to create this credential on AWS because we want to create our resources in AWS. You'll not be able to create any resources in AWS unless you have a connection. If you don't have anything that connects you to AWS, you cannot create any resources. So the first thing that you want to do is to create your access key and the secret key. These are the 2 things that you need to do, right? But before you do that, you need AWS CLI, right? To be able to do that. So the first thing that we'll need to do here, go back to our mobile extent, will be to install sudo apt install AWS CLI. Is that the has no installation candidate? So we can sudo apt update. Is that what we need to do, right? Let's update this and see what happens. Okay, I've updated that. Let me try to install that CLI again. Now I'm able to install the CLI. So because I want to communicate with AWS, I need that interface to be able to communicate with AWS, right? I cannot communicate directly, right, using my CLI. So I need AWS CLI. So I'm installing that AWS CLI right now. That aids in the communication so I can talk to the API in AWS, right? Once that is done, right, now you can now go to AWS. Let's go to AWS and create our access keys and secret key, okay? So now I'll go to my AWS. Right, this is my AWS. Okay, there are two ways you can do this. You can go through your IAM, right, resource to create this. The easiest and simplest way to do it is if you come down to where you have this your name, right? If you come down here, you can come to security credentials. In this security credentials, if you go into the security credentials, it takes you into your IAM management console, right? In your console, either you go through, that's the easiest way, or you can go and do a search for IAM. Once you do a search, it will bring you to this interface or console. So once you get in here, you see, here I have access keys. I have 2 access keys that I've created already. I think the max you can create is 2. It won't allow me to create any other one. You see right now, it grayed out, right? So let me see the longest one. This is the longest one I've had. I'm going to delete this one. So it would allow me to deactivate this. I need to type in this code to deactivate it, right? Deactivate, right? It wants me to enter this code to deactivate. So that is deactivated. Now, see, it gives me the ability to create a new one, right? Now I can create an access code now. Create an access code, right? This access code is not, once you might not be able to get the secret code anymore. So you may want to get it and save it somewhere. So this is your secret, right? I've copied my secret now. And don't share your access code and secret with anyone. It should be confidential. If someone has access to your keys and your secret key code, a person can remotely create resources on your AWS account. And guess who's going to pay for all those resources? You will be the one that pays for all those resources. So you don't want to do that, right? Continue without viewing download, right? So I have it here. So if I go back to my my mobile extent now I can run this code, AWS configure, right? So if I clear this and type AWS configure, right, that is going to ask me for my access key ID, right? So the access key ID is the first one that I copied, right? I will enter that in here. Then it's going to ask me for my secret access key, right? So my default region is going to be US West 2, but I can leave that without putting anything in there, right? Now I have configured my access key and my secret key. Now I have ability now to provision resources in AWS, right? Once I do that, now I can install I can go ahead and do installation of Terraform. So, but I'm going to use Linux operating system. So you can use any of these ones, right? Let me see. Let me open this one so you can take a look, right? So this is the official installation website. You can just copy this, right? So what this does is you download, wget downloads this package for you, right? You update it and it's going to install it automatically for you. So I can just copy this right here, go back to my mobile extent. If I paste this in here, paste this, 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 That's all you need to do. And if I do Terraform -v, right, it has installed my Terraform for me, right? It's as simple as that. That's the updated one. So the reason I don't take you to my GitHub installation guide is because this is updated. This is official Terraform documentation. So they update this and keep it up to date, right? So the package here is updated, right? The versions are updated. So if you're using Ubuntu and Debian, if you're using a Red Hat server, this is what you're going to use for the installation. If you're using Fedora, this is what you're going to use. Amazon Linux, Homebrew, and so on and so forth. So all these are updated. So if you're want to install in Red Hat, that's fine. Fedora, Amazon Linux is updated and it's kept up to date. So the link I have in here will take you directly. Where is my link? This one. Let's try this one. Let's go back. Okay, this link will take you directly into that. And you also have, right, you also have these instructions. This is manually will take you through step by step. You want to do step by step installation, right? It will also help you to do that. But this is official documentation, right? What I did was just copy that one script and paste, and I was able to do the installation, right? So that's how you install Terraform. It's as simple as that, right? I'll share this GitHub repository with you, and anyone has any question on the installation of GitHub, remember the first thing that you do, right? The first thing you do is, first of all, you have to download AWS CLI, right? And you can download it using, you can see it's AWS CLI installation. You can go in here to the official documentation. This is Linux, right? You can do sudo yum. Oh, this is if you already had one, if you want to remove it, right? You can just do sudo app install AWS CLI, right? This is to remove it, the installation, or you can use the script. These are the script also that you can use to run it. You can just copy the script and run it, and it will install the AWS for you automatically. This is the official page, or you can do it the way I did it, right? Okay, that's the installation of Terraform. So what else do we have to cover? Okay. The next thing we have to cover, this is the installation, the basic commands, right? The basic commands in Terraform. So I explained this already when we started. These are the basic, what is called Terraform workflow. It goes from left to right. The first thing you need to do is you create a folder. Whenever you want to write a Terraform manifest file, it always requires you to create a folder. Once you create that folder, then you can do initialization. Initialize that folder. When you do the initialization, right? No, you create a folder. Inside the folder, you write the script. Then you initialize it. Once you initialize it, because you have the manifest file inside that folder, then you can do a validation to see your manifest. If there's anything wrong, any syntactic error in your manifest file, it would flag it so that you know that there's an error. Now, once you're done with that, you can do Terraform plan, right? Once you do Terraform plan is going to show you all the resources that is going to be created. Now, once it shows you that and you're okay, right, then you can do Terraform apply, and Terraform apply would now create all those resources for you. Now, after you've created, you want to do a cleanup, you want to remove all the resources. Don't go and try to manually remove the resources one by one. If you're creating a resources or any resource using code, try to destroy it using Terraform destroy. Otherwise, what I've noticed, my experience in the past is I created infrastructures. Then I go in manually and delete one infrastructure. It's not going to delete everything, dependencies that are being installed with that resource that you install. So what happens is, in a cost, by the end of the month, you will incur some costs. You have some costs. Amazon will send you a bill, right? And you said, I did not create any resource. I destroyed it. No, you did not. You destroyed just one resource. There were dependencies that were created alongside when you did that you did not delete. Amazon charges you. I've incurred a lot of costs on that. So that's my experience. And I want to tell you, if you create any infrastructure using a code, use the destroy to destroy those infrastructures, right? So destroy will clean up everything, do a total cleanup of your system for you. Don't try to delete it manually, okay? And again, that's the explanation of that. And these are the core commands. For Terraform init, use Terraform init. For validate, use Terraform validate. And for plan, use Terraform plan. Then apply Terraform apply, then Terraform destroy. It's that simple. That's the workflow. Those are the commands. So let's go ahead and see how we can do a hands-on, create a simple EC2, right? Don't worry about the manifest. We'll get into how you develop the manifest file. We just want to demonstrate how to create a simple resource in AWS. Okay. So I'll take this one back real quick, and I'll take a look at, this is a basic command, right? We've already talked about this basic command. This is what is called, okay, let's talk about this before we do a hands-on. Okay. This is the basic command, right? Right. Now, you have different, what you call blocks. Is this the place to talk about this? Okay, let's run a simple, let's create, what I'm going to do now is to create a simple EC2. Then we'll get into different blocks, right? I don't want to get into the blocks right now. Now, this is a manifest file. This is a manifest file to create an EC2, right? To create an EC2, you first of all, you have what is called Terraform setting block. The Terraform setting block has what is called a required provider. So this required provider that you have to state has to be, who do you want to provide these resources from? Is it AWS? Is it Azure? Right? So that's what this block is, right? It sets up and it creates a version of the resource that you want to create. Now it has a provider block as well. Now the provider block actually goes into the details of, okay, I want to use AWS, and this has to match this, right? Because this is the required provider that you want to use. And when you get into the provider block, then has to define in which region do I want to create this AWS, right? This is where you have the provider block. Then you have the resource block. The resource block then goes into the details of what you want to create, right? Don't look at all these codes. We'll get into writing how to write all these codes. But the thing that you need to be able to create this infrastructure is what is called the AMI, right? I think we talked about AMI when we were doing AWS last week. AMI is what? So AMI is the image, Amazon machine image, right? That you have. This image is what controls, or is the engine, or is actually the instance that you want to create. This is the code that identifies the kind of instance that you want to create, right? So in this case, let me show you. Let's get back to Amazon AWS screen. Where did I have it? Here. I have three screens, so I'm trying to figure out where things are. Okay, let's use this. We can actually open. Okay, this is it, right? So you get back to services. If you get to EC2, if you get to EC2, let's look at the instance we've created already. Or if you want to look at IAM, you can, not IAM, Amazon Machine AMI, right? There's catalog here that shows you the catalog for all the instances. Let me see. Is that a catalog? That's not what I'm looking for, right? All right, we can see, so these are the images. So you can go here to the images, right? So this will show you Amazon Machine image. Let's get to the catalog. Okay, so the catalog will show you all, for example, Amazon Linux, Amazon Linux 2. So this is what we call the AMI, this number. So if, for example, if I want to provision Amazon Linux, I'm going to come to this and copy this number, right? In this case, I want to create an Ubuntu server, right? So what I need is this AMI. So I'll copy this, right? So where I have, okay, let me copy this block real quick. Let me get to my CLI. So now that I've installed, I can go ahead and create a folder, right? Sudo make directory, like Terraform. CD to my Terraform. Okay. In this, I want to create sudo vi my first ec2.tf. Okay. Okay, so let me go ahead and copy this into this. Okay. All right. Now that I have this, let me get back to my AMI. copy my AMI. So what I want to replace in this AMI is this one. Okay. So another thing I want to replace is, I have copied too many things in there. Okay, so I've replaced the AMI. So what type of instance do I want to create, right? So I have an AMI there. So what type of instance do I want to create? So I can go back, let me go back to my AMI, right? So you notice that this does not really tell me exactly what type, but I can use this AMI to create T2 micro, T2 medium, T2.
Hello, doctor.
Yes.
Can you hear me, sir?
Yeah, I can hear you.
Yeah, there is a way that you can identify the AMI of what particular instance that you want to create, depending on whatever. So if we go to instances, for example,
Yeah.
and then we go to launch instance.
Yeah, you get to launch instance, yeah.
Now come down
Okay.
maybe for Ubuntu, that will choose that Ubuntu.
Okay.
Yeah, immediately you choose that Ubuntu on the top right hand, under where we have that one, you see the AMI there.
Yeah, this one right here.
Yeah,
Okay.
it's easy
Yeah.
for you. It's easy for you to copy it on the right hand where we have one on the up. Yeah, no, on the right.
And this one, right?
That's it. Yeah, but it is always easy. It's easy for you to copy it on your top right hand where you have summary.
Yeah. This one right here. This one.
Wait, let me.
This one or this one?
Here.
On this side.
Do you see where I circle? Yeah, here. Yes. Yeah,
okay,
that's
right here.
Yeah,
Yeah.
So if we change the instant type, that is T2 micro right now. If you come and change that instant type, that AMI will automatically change as well, the one that we are having there. So
okay, so for example, let's come back here to T2. For example, we want to create T2 medium.
Yes.
Okay, so this will change here automatically.
Yeah.
So you can copy this.
Yeah.
Right here. Oh, I have maybe I should create a new file. I have just for demonstration. So this is the one that I have. If I VI into my file.tf, right? So this is the code that I have. It has a provider a setting block right here, right? And it has a provider block right here, and it has a resource here to create an EC2 instance, T2 micro, right? And I have a tag here that names the instance as it's being created, right? So it would name it as app server, then it would keep counting if it's 1, 2, 3, 4, 5, depending on the number that I choose to create. So it would repeat that number. So then I have, when it creates it, I wanted to also create a key pay, and my key pay is class key, right? So it has the provider is creating this instance in AWS. That's my provider. This is the setting block, this is the provider, and this is the resource. So just 3 blocks: the setting block, the provider block, and the resource block. Those are the only 3 blocks that we're looking at today. And we'll get into how do we write all this. We'll get into that in a minute. But I can run this. Let me save and close. Oh. What is the command to close without saving? I keep forgetting this.
You just use Q.
No, Q will just save it and close. But yeah, okay, save and close. Okay. All right, now we can run this real quick with Terraform. Let me initialize it. That's the first. So this would initialize the backend and create your state file. Then we can run Terraform to validate. Okay, then we can run Terraform plan. Okay, so this will create all the plans. So here it tells you exactly, see all the things that we'll create for you. You create an AMI. And remember, this is the AMI ID that we put in. We'll create this. All these things known after applying. So before it's going to create this, then it's going to associate all this to it, right? And so all these resources is going to create it. It's creating it in a default VPC. So all this subnet is going to be after, because I'm not creating a new VPC. So it's going to use the default VPC. It's just like you're going to create an EC2 without creating an EC2 VPC to house your EC2 instance. So all this is going to be, every other thing I see here, it's creating it on a default resources, which are the dependencies. Okay, I'm not creating. So all I'm creating here is the EC2. So it gives you this plan, and you know exactly what it's going to create. Then once you do that, you can do Terraform apply. Right. And go back to my let's go back to my, right. So this is my AWS. You see, this is the only instance that is running right now. I'm refreshing it so you can see it. It's loading. This is the only instance that's running right now. So with that code, I'm going to create a new instance, right? So let's get back to the code. Okay, now it's asking me, yes. All right, now it started creating the resource, which is my instance. So give it a few minutes. All right, so it started the creation. So this is automation in process, right? You're using your code that you write to create an instance instead of doing it manually. So that's what Terraform is all about. Okay, now apply complete. Resource 1 added, 0 change, 0 destroy. So we go back to instance, AWS. If I refresh this right now, let me refresh this. Right, now you have this server created. Okay, automatically I did not do anything. All right, and it creates it. I think, yeah, I also asked it to create a key pair. So it created a key pair for me, class key. I did that. So this is created through automation. This was created manually. This one I'm creating it through automation using Terraform, right? So that's what I wanted to demonstrate yesterday. Let me see if anyone has a question before we continue.
I have a question.
Go ahead, sir.
So we just provisioned that instance using that particular code, and then we had commanded to create a key pair for us, and then use that key pair. Do you want to also use our class key, use any of the key pairs that you have, your personal key pair, that is not the one, that file is not the one that is creating it, and replace it on that one, and then change the name of that server, and let's see what happens.
So let me see what you want me to, okay, get one of my key pairs, change it here.
Yes, the key pair that you already have, because you already have some key pairs already in your system, right? You use one of your key pairs, because this one you are commanding it to create a key pair for you, and let's see what happens.
So I want me to use this key pair here. Plus I have Sona. Right. This is just.
Sona is the name of your key pair?
I have a key pair called Sona, yes.
Okay.
Yeah, I'm gonna start a key pair, or I can use another one. I have a lot of them. So I have Sona.pem, so I can create this one as well. Okay. Now, yeah. So let's use this one. You see, this is just a comment. When you see this hash, this is a comment. If you see this is a comment, all right? Yeah. There are 2 ways that you can do a comment. You can use this as a comment. You can also do this. If you want to do multiple comments, slash this. So this is. Okay. And you can close it this way. Right. So this is how you do multiple comments, right? You start with /star and end it this way, right? So if you want to comment, do multiple line comments. This is a single line comment. This is just giving you information about this line. But if you want to do a entire comment on multiple line, you can write it like this. We'll get into the syntax of all this. Just wanted to show you that just in case. So you don't feel this is part of the code. This is not part of the code. It's just a comment, right? And this is not part of the code. It's just a comment. Okay, let's rerun that.
Yeah, and then in that Amazon machine image that you are using, do you want to change that Amazon machine image as well? And then let's just see now what is going to be the outcome is going to be. Just pick up an Amazon machine image from our GUI.
Yeah, my brain is getting. I'm trying to. What's
just click Q exclamation.
Column Q exclamation. Yeah, that's what that's what I've been struggling this morning. I need to take my tea or my coffee. Okay, so let me sudo this because it will not allow me to serve. Oh, what did I do? I need to sudo this. So what's my file? Sudo vi my file.tl. Oh, did I wipe up everything? I clean it up.
I don't know. You just quitted.
I did something wrong. I cleaned it up. I cleaned up that file. Yeah, I cleaned up that file. Okay, that's no problem.
You still have it, right?
I can bring up, yeah, probably then have the exact one, but I have this one that we were trying to run yesterday. Let me bring this up. Okay, so let's change this, the AMI, real quick. Let's change the AMI. So what did you want us to enter the?
Yeah, that other file had instance. It had keeper. It had keeper, which was your keeper.
Okay.
No, which was a keeper that we were instructing it to create. But this time around, I wanted us to use your keeper.
Okay.
And then change the AMI.
All right. So let me bring that command again real quick. It was a tag command. Hold on a second. Okay, so I can add a key pair. Within the instance, I can also add a key pair here. I can include it in here. Okay, so the key pair I want to use is, let me use, okay. Right, so, all right, so this is we also have to change I need to change this to, you see, US West 2.
Is it?
US West 2, and I need an AMI.
Mm-hmm.
So let me get an AMI. So we're going to create T2 micro. Okay. All right, so that's what we have. And this is an Ubuntu server. This is just a comment, so this is not part of. Just want to make sure that comment is right. US West 2. Yeah. All right, we can save this and close. Let's see if, let's initialize a file again. Okay, let's make sure the code is all right. If there's any error, it's going to pop up here and tell us, yeah. All right, it says the code is okay, so we can do Terraform 9. Okay, so then we can do Terraform apply dash auto.
When you run that Terraform plan, there was something that it showed you on the output. It said 1 created, 0 added, I think 0, 1 destroyed. I wanted you to talk about it.
Okay. All right, so it says 1 to add, 0
yes.
to change,
yes.
right? 1 to destroy. So we had already created, we created an instance.
Yeah.
And we are updating that instance using the same file name.
Yeah.
And it's a different AMI that we're using now.
Yeah.
So what's going to happen is going to destroy that one that we created.
Yeah.
And it's going to create a new plan now for us, a new plan that would include a new AMI and a new key pair that we just created.
Yeah.
So that's what it's going to do now, right? So it's going to replace, if nothing was changed, you'll see 0 added, 0 change, and 0 destroy. You will not do anything because it has what is called idempotent. Idempotent means that it has a state file that it created. So that state file is stored somewhere. Now, when you create a new plan, it's going to compare the new plan with the old plan and see if there's any changes in those two plans. If there's nothing changed in any of those state files, then it's not going to do anything. That's idempotent. Now, if anything changes, it's going to completely destroy that other plan and create a new one for you. So that's what that means.
Thank you, Doctor.
Yeah. So now we can create Terraform apply. I don't want to stop and say yes. So we do -- auto approve. Auto approve is, instead of me asking me to say, remember the place I say yes, right? I'm not going to stop to say that, but okay, let me run this with yes. Then we'll run that again with auto approve. So now while it's trying to create the resources, it's going to ask me, right? Terraform will perform the actions just described above. Only yes will be accepted to approve, right? So the reason I wanted to put that auto approve was so I can skip this. Now I can say yes. Then it will start creating the instance for me. So you have used that auto approve. I would skip that step that says, yeah, we have to ask this question. Are we all getting it? We all understanding this? All right. Does it look complicated? Mr. Benga, how does it look so far to you?
A little bit.
All right, you're getting it little by little, más o menos.
Yes, sir.
Okay.
Más o menos.
All right, so now it says apply complete. Resource 1 added, 0 change, 1 destroyed, right? So it has destroyed the previous AMI and it has created a new one. You can see this one that it destroyed, right? It gives you the UUID. We call it UUID to identify this. Now it has another ID here that is created. Now it destroyed this one and created this one. So we go back to.
Hello, Doctor.
Yes.
So before you continue from that, I just wanted you to be where you were.
Oh, go
in
back
that
here.
command line. Yeah. So before we, it has given you the outcome of what you just said, and then you did mention that because when you were explaining that 1 created, 0 added, and then 1 destroyed. And then you did mention of the Terraform state file, that it is this Terraform state file will compare the previous one that was there and replace it. And that is why it was deleting that. It was showing that because we have a new AMI and then we also have a new key pair. And that is why it is showing that this one was destroyed. Mm-hmm. Now, what is that Terraform state file keeping? That Terraform state file that you mentioned that is going to compare it. What does it keep for us?
What it keeps?
What does it show us? Yeah, because you say it is a Terraform state file will compare the new code that we just know, and they know that, okay, things have changed and this is what it is showing us now.
So the question is, what is that state file?
Yes.
Okay, you can actually look at the state file. Let me see if I can have the command. So it's more like it's a plain text. See the command that you have here for it to create this, right? This is the file that it keeps. Well, it keeps it something like this. This is what you want it to create, right? Yes. And it will keep these resources that you want it to create. Now, it keeps it in a plain text. Right, I'll see if I can get the file. I think it's Terraform state.tf. I'm not really sure. I can look it up. .ts. Hold on. Let me see if I'll be able to. .ts state. No, into .terraform state.tf. No, I'll look it up for you. Yeah, I'll look it up for you. So it creates that. That's what it's now. When you're creating a new file,
are you talking about that? The name of that file?
Yeah, I think it's .terraform. Do you have it? I think I have it somewhere.
The name of the file is Terraform. So it could be something, but I've always used Terraform.tf state.
So VI Terraform. .ts states, right? TF state. Let me see. Yeah, I think, yeah, this is the file. This is what I was looking for.
Yeah.
So this is a state file, right? So once you see it has all these resources, right? It has the resources that it's trying to create. So it would store this. So when you create a new one, it's going to compare that one with this one, right? And see if there's any difference. If there's a difference, then you create a new resource, right? If there's no difference, it's not going to create any other resource. So that's the question you're asking, right?
Yeah. So in other words, what we are saying is that the Terraform.tf state file shows you the current state of your infrastructure, right? And now if you now try to bring in like what we did, changing a code to apply it to run a Terraform plan, it will now compare what it had in its own current state of infrastructure with what you are trying to bring in, which means it will now be reading what you are saying. And then it will now say, okay, because of what you brought in, like what we did, changing the AMI and then changing our keeper, comparing it with that current state of infrastructure, current state of the infrastructure that it had, it will now say, okay, you are trying to initiate this, so it's going to destroy this and then replace this by this. Is that what that sounds like what you were doing, right?
Yes, exactly. Yeah.
Oh, thank you.
Yeah, that's what happened. Okay, so let's get into some basic languages, right? Code in the Terraform language is stored in the plain text file with a TF file extension. So when you're creating your file, you have to use the extension TF. You see, for example, when I created this file, right? I created this file, I created with .tf file, right? It has to be end with this TF, right? And this is the file that is created. This is the state file right here that Louis was talking about. So this is the state file. Once you create that, it's going to create this state file for you. And this is the state file that I was struggling to see what the file name is, right? So once you do that, it will create that file for you, okay? But the extension of the file that you have to create needs to end with a TF, okay? All right, there is also a JSON-based variant, all right? You can also look at it as a JSON file of the language that is named with the .tf.json file extension. Files containing Terraform code is called Terraform configuration, right? Or you can call it Terraform manifest file. So either configuration files, short form is always configuration file, or you want to call it manifest file. Now, when you call it manifest file, you get it confused with Kubernetes, because Kubernetes file is also called manifest. So you have to specifically say Terraform manifest, right? Otherwise, you can say configuration file, Terraform configuration file, okay? So that's for the file. Then there are some core commands that I want to talk about. Now we want to get into the blocks, different blocks. What are the blocks? Arguments, identifier, comments, right? Let's get into that real quick. So the first is a syntax here, so, right? So the first block of code, we'll get back into the code. You see, for example, you have resource and you have this label. So this is called a block and this is called a label. But before we get into the nitty-gritty of this, right, let me show you different kind of blocks that we have in Terraform. I think if I use my GitHub repository, it will serve us better. I have a better note in GitHub repository. So the question is, how do you write this Terraform manifest? What are those things, those elements that play into the Terraform manifest? I have a lot of Terraform repositories. Let me use this one. I think this one simplifies it better. Let's get into Terraform basics, right? Into the basic commands. We already looked at the basic commands. So this is the block. We have, this is the, okay, let me take a look at this real quick. We've done this already. So which Terraform init validate. This is the Terraform block that we just ran. This is the manifest that we just ran. This is what the manifest looks like, right? And in this manifest, like I explained earlier, you have the setting block, you have the provider block, and you have the resource block. But those are not the only blocks that you have in Terraform. This is just, and this is example, this is a replica of what we ran. Let me get into language syntax real quick. Now, this is where I wanted to go. This is the syntax. You have it, this is more or less like a template. When you're trying to write a provider block, right, it has what is called a block type. Then you have a block level, then you have another block level. In some cases, you only have 2 block levels. But the type, for example, is like your resource. So you have a block type. In this case, it's resource. Then the next one is the block level. In this case, it's AWS instance. This is the level. This is another level that you have. So this identifies what you're trying to. In this case, you're saying, okay, what resource am I trying to create? You're trying to create an instance. And this is exactly how it's labeled, AWS_instance. And what's the name that you call that resource? My resource is AWS instance. And what do I call it? What do I label it? My label is EC2 demo. So this is what I can change this to whatever name I want to call it. It's like when you're trying to create an instance, for example, you want to create this Ubuntu instance, it gives you what name do you want to call it? You want to call it EC2 instance, right? So you're identifying the instance by creating what you want to call it. The same thing is what you're having here. So this, once it sees this resource, it will know that you want to create an instance, and it would attach this name to that. I'll get into tags later on. You can also use the tag to overwrite this name as well. You can tag it using a different name altogether. Then you can get into AMI. Okay, now what you want to do is we want to create an instance. Then we get into the block body. What do I need? So you get into identifier and expression. So what's the identifier? What identifies the resource that I want to create, right? So on this other hand, on this other side, on the left-hand side, you have AMI, and this other side, you have the AMI number, which you can also call argument. So this is an identifier, this is an expression. All this is called an argument because you always have argument and identifiers. Now, your identifier is the object. Then the expression is what you want it to be, you want to call it, what it actually is. In this case, AMI is the identifier, and the expression that you have as the argument is the ID that identifies that AMI that you're pointing to. By the way, your resource is an instance, and what goes into that instance to make it an instance is these other things that you have. Instant type. What type of instance? T2 micro. Those are the contents that make up your instance, the resource that you're trying to create, right? So in this block that you see here, you have the instance, the name of the instance, then AMI, and the instance type. That's the resource block. Okay? That explains a little bit of blocks, how this is written. So you can use this as a template. So when you want to create a resource, you can go by that. Then let's get a little bit into arguments, attribute, and meta arguments, right? There are some resources here that I want to point you to, but where I really want to get into this is, I think I have it up here to the registry, right? In this registry, let me take a look at. So you have arguments here, right? You have attributes, argument attributes. You see arguments. So these are all arguments, like the AMI, right? Is arguments. Associate public IP address. Okay, let me see. Okay, this is let's assume we're looking for EC2. Let's see if we can find an EC2. So this is an EC2. Okay, so for example, we want to create an EC2 resource. EBS default KMS key. That's probably, let's look for something that's a little bit simpler. This is a volume that is attached to EC2. There's AWS AMI, right? There's an AMI. So this AMI, every resource that you have what is called argument and attribute. So let's take this for an example. So when you have a reference here, it will give you that some that are optional arguments. There are some that are required, right? When it says required, you must use it. For example, this is optional. When you're trying to provision your AMI, right, this is an optional tag that you can put in. You don't need to. You don't need, all these are optional. So it says optional, most recent is optional, executable is optional. So even if you don't include any of this and you just enter your AMI, just like you see what we did, just the AMI name is going to run. All these rejects, honors, and all that. You can also identify this, your AMI, with all these other arguments, but it's optional. So AWS is not going to hold you back because you do not do that. Let's look at an instance. This is an AWS instance, right? Now, let's look at the reference arguments, right? These are arguments. Instance ID. If you want to output the instance ID, you can do it, but you don't need to include that as an argument, right? These are optional. These are optional. So to create this instance, all you need is the AWS instance, right? All these other arguments is optional. You don't need to include them, right? But if you want to particularly get into maybe the you want to identify which instance and create a documentary, create a version, then you can use all these options. The ID is optional, instance ID is optional, instant tags is optional, the filter is optional, get password is optional. This is optional too. Let's look at attributes, right? These are attributes that you can also use, right? So the AMI is an attribute, ARN is an attribute, associate public IP is an attribute, and you see this attribute when you're trying to create a VPC and you want to attach your instance to a VPC. That's when you actually try to use some of these attributes, right? Because your VPC has to contain exactly what you need in your VPC. That's when you use most of this attribute. But if you just want to create an AMI, right, you don't need to include all these attributes, right? So attributes, arguments and attributes are two things that you should know about Terraform, right? Because it helps you configure your manifest file exactly how you want it to be, right? Okay, so those are some of the languages that I wanted us to understand. So let's get back here. So this is the block type, and this is the block level, okay? I have another one here. Okay, so the arguments I was talking about, arguments and identifier. These are arguments and these are identifiers, right? When the AMI is an argument and whatever you have on this side are identifiers, okay? Then I already talked about how you write comments in Terraform. This / is for single line comments. Then you want to comment on multiple lines. This is what you use for multiple line comments, okay? But let me get back into this real quick. There's some other things I want to show you on the languages. I'm going to get back into my GitHub repository.
So what I'm seeing there for double line comment, Doctor, is not what we used the other time.
Or what did we use last time for double?
It was asterisk slash, and then we were closing it with slash asterisk.
Yeah, it's the same thing.
Okay.
So yeah, it's the same thing. Yeah, you start with slash asterisk, then you close it with asterisk slash. Yeah, do we have it?
I was looking at the one that has double this thing up there where we have Ubuntu.
Which one? This one?
Yeah.
Okay, yes. So this is, yeah.
Yeah, so you can either use...
So you can use either this one or this one for single line. Yeah, you can use this or this for single line.
Okay, thank you.
Yeah, single line comments. Then you use this one for multiple line comments. The same thing if you're writing a C++ program. This is also used for comment. This is also used for comments as well. Yeah, it's common. I think Java uses the same thing as well. Right. Okay. All right. Let me go back to this one real quick. Any question as we continue? There's some other references and okay, we'll look at this meta arguments. So this meta arguments is something else that I want to tell you about. So meta arguments does something different, right? It changes the resource. Use the depend on, for example, depend on meta argument to handle hidden resource or model dependencies that Terraform cannot automatically infer, right? So all these other arguments that we're using doesn't change anything on your Terraform. But when you use a meta argument changes what you do. For example, if you create an instance and you want to change the count or the number of instances, you use what is called a meta argument. For example, count, C-O-N-T, right, will change the number of instances that is you create, will change from 1 to 2 to 3 and so on and so forth, right? If you use depend on means that this argument, this needs to be run before this happens. So depend on means that what you're trying to create depends on this. Okay, for example, we want to create a subnet, right? Your subnet depends on your VPC. Or the subnet numbers that you create, it depends on the CIDR block of your VPC, right? So you cannot create your subnet separately without creating your VPC, right? Or you cannot create an internet gateway without creating a VPC, right? So that's where you can use depend on, right? So that when it's creating, it's based on what you already created already. So there's various examples on how these are used. So these are all called meta arguments, right? Let me see this particular example. Policy, do we have an example of meta arguments here? Okay, so depend on. Now they use this depend on. This depend on IAM role policy. So for you to be able to create this, there must be an AMI role policy that gives you the privilege to create these resources. So in this particular manifest, this creating of this, if you don't have the privilege to create this, right, it's going to, okay, this is actually creating the IAM role, but you have to be based on IAM policy, right? If this IAM policy is not in place, you'll not be able to create this IAM role, meaning that you have to create a policy, and the policy has to give you a privilege, like an elevated privilege for you to even create the IAM role. So if you don't have that privilege to create IAM role, to create people into your organization and give them granularity about what role they should play, you cannot even create this IAM role. So all this depends on some policy that you've created that given me an elevated privilege to create this. So all that is called meta argument. So this is another meta argument. For example, count, right? Like I told you, you can use count to increase the number of instances that you create. So everything the meta argument does is it changes the original form of what you created. So in this case, it changes this to creating 1 instance to creating 4 instances. Okay. If you want to create 4 instances, you can run this to create more instances. Another meta argument is for each, right? Now, you can create, in this other particular example, you see, it wants you to create instances of this resource, which is an Azure resource group, in each availability zones, right? So it's going to create one in East US, another one in West US too, right? So it's telling you that for each availability zone, create a resource group, right? So that's what it does, right? Let me see this one, provider. All right, this is just a provider block that gives you, it's also a meta argument that give you aliases. Now you have aliases. Your provider is Google, but you have an alias in Europe. The region is Europe West 1, right? But the provider is a meta argument, right? This is a lifecycle management. If you want to manage your lifecycle, managed cycle is always about creating, updating, and destroying your application. In this case, it's showing you a lifecycle, create before destroy is equals to true. So it tells you what to do with it. You have to create before destroy. If it's false, right, then you can destroy without creating, and so on and so forth. So all these are called meta arguments, right? Okay, this is the resource block I was talking about last time. So this is a block, right? This is a resource block. Then you can get into the resource behaviors, right? The dependencies, the local only resources, and so on and so forth. So all these are contained in the documentation, in Terraform documentation, that I also, if you look at this other, not this one, I have a lot of documentation in this PowerPoint slide, right? That gets into the details. If you want to read over this, you can see a whole lot of the documentation that I have here. I like to use this because it gets into the details, but I found out that if I can get into the documentation and start showing you what is in the documentation, and you can go into the because you can get all this information from Terraform. They have I think is the best documentation I've seen, because you don't really need to know the codes. You can just extract the codes from there and you can run whatever you need to run, okay? But this, what I put together gives you a step-by-step. For example, if you're trying to create your Terraform file for the first time, right? For example, this example gives you how you make up your directory, right? You change your directory, then you create your first file, right? Then you can use the Terraform init, Terraform, you can use format as well, validate, and so on and so forth, and apply to be able to get to your state file and be able to, when you do apply, you're able to create your resources. And it gives you example of the state file. This is the state file and you can also do Terraform show to show you exactly what is going on. So if I run a command like, say, Terraform show, right? If I run Terraform show here, we had a resource that created. So it's going to give you the resources that was created, all the resources that we had created, right? So after creating this resource, okay, another thing is you can destroy this resource completely. All the EC2 that we've created, all the resources, you can destroy it. So if you run Terraform destroy, right? So Terraform destroy is going to, if we go back to this, let's say yes. Let's say yes. What did I do? Terraform destroy -- also approve. I don't want it to ask me to say yes again. Right. All right. So it's not going to ask me that question yes again. So now, so it's destroying that. So if you go back to your AWS, let's look at AWS now. They're looking for my EC2 instances. Running instances. Okay. You see, it has destroyed that Terraform that we created, right? It's already gone. Go back to our code. So it has destroyed that. It's still destroying. Destroy complete. Resource destroy, right? So it has destroyed that. Terraform Apply. I can run Terraform apply again. Right. Yes. And it's going to create that again for me. Let's go back and take a look at it. In a minute, that should create an instance for us. Let's see what it's doing. It's still creating an instance. In a few minutes, it gives us an instance here. Okay, see our instance is creating right now. It's created already and it's running. Yeah. Verify just again. Okay. So it has created a new instance for us automatically, and that instance is running. Yeah, we can go back and totally destroy this instance. Destroy the dash auto. Right now, you can see that that instance is being destroyed. Okay. In a minute, that instance should. That instance is destroyed. It's completely destroyed. Everything that it provisioned is gone. Okay. Right. So that's the power of Terraform. Time. Okay. Let's take about 10 minutes break. Let's be back at 9:17. Real quick. Okay. Any question before we take a break? Hey, David. Hi, David. Hey, David, are you at work today? Let me pause recording.
Yeah, I can hear you, sir.
Okay, so the next thing I want to talk to you about, I want to teach you, is the different kind of blocks that you have in Terraform. So when you're writing blocks, we already showed you the first fundamental blocks, which I talked about, like the Terraform block. That's the initial setting blocks. It's called Terraform setting blocks. Then you have the provider block. Then you have the resource blocks. Those are called the fundamental blocks. And the setting block, let's get a little bit deep into the setting block. Let's get into the documentation. So, first of all, when you want to create Terraform, you have to create what's called the setting block. The setting block is where you actually do the setup to show you. So when you run Terraform init would go to your setting block. And from the setting block, and it would find out where you want your resources to be provisioned, right? And there are certain versions of Terraform that you want to run, and it's going to also look at the version as well, right? That is associated, because every Terraform has what is called a plugin, and how all the providers are linked to Terraform is through plugins. Is the plugins that get a connection to their API, REST API, which is the interface that they communicate with. So those plugins is what Terraform would go and look for first, okay? What version of Terraform do you want me to use? What source am I looking for? So in your setting block has what is called required provider. This is how you write it, required provider. Then the provider that you want to use is AWS. So AWS, then you open a bracket, then the version, this version has something to do with the version of Terraform, right? This is not a version of AWS. This is a version of Terraform that you want to use, right? And in some case, you see it written like, let me show you this. Okay, let's get back to that, add my file. Right. Sometimes you see it written like this. Okay. It has this what is this called? Tilde. This tilde, then you have greater sign. So what does this mean? This means that this version is constrained, right? It's constrained to anything from 3.21 version and up. So 3.21, 3.22, 3.33, right? 3.44, and so on. So if they have any new version, so it's tilde greater than anything that's any major version that is being released, right, is going to capture this. Otherwise, anything less than this is not going to be able to run, right? If you're running a version, any other version less than this. So any version, any new version, right, it will update itself automatically. So that's this little tilde. That's what it means. Right? So this is a setting block, right? And this setting block like I said, has to have a required provider and the provider. Then it has to have what's called the source, right? In this case, you see HashiCorp AWS, right? So let's get back to this. This is exactly how it looks like. HashiCorp AWS, right? If you're using Azure, you can also state it here, Azure, and so on and so forth, right? So that's your setting block. That's the first block that you need to set. That's still part of the fundamental block. Another block that you need to set is the providers block, right? So we go here and look at the providers block. Providers block, let's look at an example. Providers block is all about who is providing me, who am I using to configure the resources. In this case, it's AWS, right? And if you look at, I don't know, let's look at, they have a configuration here. See, for example, this is provider, Google is the provider. In Google, it has a different way of configuring this. You have projects. SCM, this is the name of what you want to this is the name of your provider or whatever you want to provide provision. Then it has the region. You have to set the region. It's different from AWS. Let me see if I have an example. This is an example of AWS. All that is required here is the region, right? So you have provider AWS. All you need is as a requirement is the region. You can also use alias, right? And so on and so forth. But these are optional, like I showed you when we're looking at the attributes. This is optional. All right. So this is the setting block. The setting block always starts with Terraform, right? The provider block always starts with provider. Okay. All right. So that's let me see. Okay, now we can get into the requirements, right? Talk into the requirements.
Hello, Doctor.
Yes, go ahead.
Sorry to interrupt. So by provider in that situation, you are like telling Terraform, like the code you are going to be working on should be coming from this platform. So when you specify there, like AWS, you are like telling Terraform, okay, this code that we want to work from should be coming from AWS.
AWS, yeah.
Okay. If it is Google, you are telling it should be coming from Google, just like the one you previously showed us.
Yes. And when you're setting up your setting block has to carry the cloud information that you want to provide. And your setting block has to be the same name that the block should be the same as your provider block, right? So if it's using Google, your provider has to be Google. If you're using AWS, it has to be AWS, right? So that's about provider, right? So the next thing that we have is resources, right? Now, you see how it's broken down. Now you have the settings, then you have the provider, then the resources. These resources are all the resources in, for example, AWS, or all the resources that you have in Google, right? So let's take a look at that real quick. So you can look at the resources here. This is an example, AWS instance. This is an instance, and you call it web, right? And this is this is the attribute, right? You have AMI. These are arguments, right? So AMI and instance type, these are required, right? If you have these two, you should be able to create yourself an instance. Okay, so this is how you write it. Resource starts with a resource name, and it has AMI and instance type. And let's look at the behavior real quick. Resource behavior. So it comes in here and gives you all the behaviors, how Terraform applies the configuration, how it creates it, how it destroys it, how it updates it, and so on and so forth. Now assessing resource attributes. So the attributes gives you a little bit of snippet of attributes and resource dependency and so on and so forth, right? So it gives you that overview. You can always read through this. But I'm showing you the blocks, the different kinds of blocks that you have in Terraform. Terraform block, there's Terraform setting block, the provider block, the resource block. Then you get into variable blocks. Now, in variable blocks, you have the input variable blocks, you have the output values, and the local values. Now, when we're doing, if you have a little knowledge of programming, we're doing Linux, we use variables, right? Variables are temporarily holding location that you can hold information. Then you can use that information in your line of codes. This is the same thing as well. So instead of hard coding every information that you want to go, that should go into your manifest or configuration file, you can create variables, right? So for example, you can create a variable for the AMI, right? So whenever you want to change the AMI from T2 micro to T2 medium, you don't have to go inside every place in your code to change that. You can just use a variable, and you go to your variable and change that name in that variable, and you should be able to see it called in your main manifest program. Now, output value mostly is used to when you want to create an output. For example, you've created an EC2 instance, and you want to see the ID of that instance. You can create an output value. right, that would output that value, right? And you also have a local value as well. Local value is also as like a variable, There are some things they can define in your local values that you can also use in your block as well, right? We'll take a look at some of the examples real quick. So let's take a look at that real quick.
Hello, doctor.
Yes, go ahead.
Sorry. So you did mention when you were pointing. Do you want to please go back to that that slide where you were? The slide you just left. Yes, you did mention input variable block. You said instead of hard coding. What do you mean when you say instead of hard coding?
Okay, hard coding is okay. Let's go back to examples. Okay, for example, is look at this AMI. I'm just putting this AMI value in here. I'm hard coding. This is called hard coding. This T2 macro, instead, because if I want to make a change on this, it is inside my main manifest file. That's configuration. In programming, you call this inside my code, right? So I'm writing this inside my code, which if I'm an attacker, I will get into your code and I will decipher exactly what you're doing, right? I'll see what your resources I will understand exactly. This is not an acceptable practice in programming. You're hard coding all your details. The most simplified way to do this is using variables, right? So that, okay, for example, I've written this program right now. Let's just call it program for the sake of understanding this concept. You've written this program, and 2 months, your boss asks you, I need you to go, and this is probably 3-page long program, and you have AMI, I'm just taking this as an example, repeated in that program, and you have like 3 pages long program. Your boss wants you to go change the instance that you're using from the AMI and change the type, instance type. So you have to go into each of your program and look for where you have AMI and instance type, right? And make those changes one by one, right? That's hard coding because you hard coded this. A more acceptable way of doing this is, for example, let me use this as an example. Coming here and creating some kind of a variable, right? Creating a variable, and in this your variable, you give it maybe a name, right? Name, or you can say AMI. I'll just call it AMI, and I'll call it my AMI, and give it a value. Give it a value. So give it, yeah, maybe use this value, right? Okay. Now, when you come down here, instead of using that value, let me come here. Comment this. Okay. Instead of that, you can do something like this. I'm not sure the syntax is right. My AMI. Right. So I'm doing this instead of hard coding this number in here. Now I'm calling every time. This is an example. This is the syntax are not right. So if I have a curly bracket here, I have to close the bracket here. That's all, right? So in this case, I'm calling this AMI from here. It means I'm not hard coding it. You can even take this variable and put it in a different file and lock it, right? So that nobody knows what this value is. You can put it in a vault, right? You can put it in HashiCorp vault if you want to and lock it, right? And you can only reference it so my boss now wants me to change the AMI to a different AMI. So instead of me going inside here to make the changes, I'm coming here to make the changes. Maybe the new AMI number ends with maybe 999 or something like that. So I'm just making that change here, and that's changed every place that I have this reference, it would automatically generate. So I'm just referencing this. I'm making that change only in one place. And maybe my instance type as well. Instance type as well. I have originally is T2 medium, right? T2 medium, right? And I can reference it here. This is a comment, right? I'm putting a comment here, but I want to, then maybe I put, I call this instance type. Right, so in this case, I'm not hard coding this. So previously I was hard coding all this, but now I'm not hard coding it. I'm using variables. Okay, So let's get back to it. So we're talking about this variable, input variable blocks and output values and all that. So I think we were here. So let's Terraform resources, right? We wanted to look at variable blocks. So this is, I have it here. Yeah. Let's look at an example. So this is a particular example. This is variable. So you can create your variables like this. This is AWS region, right? So these variable blocks, you have a description, the type, and you have to always have a type, which is string. You can have a type to be string. You can have it to be Boolean type. You can also have it to be numeric, right? So in this case, in most cases, it's always string, because for a region, in this case, it has to be string because it's alphanumeric. It's combination of letters and numbers, right? So this is a variable describing your region. Notice that, see these level blocks in defining a variable, you don't have 3 blocks here. You only have 2, right? And this is a block, this is a block level. Unlike when we're doing EC2, we have to define, okay, what am I? And you create a name for it. But when you're doing variables, you only have 2 blocks. This is the main block, this is the level, right? And this is optional, you can put a description, but string is not optional, it's required. And where it is default. Default is also. So this is the type example of a variable block. This is a variable block as well. This is you're creating an instant type, right? This is you're creating this variable, and you can use this variable later on. You can reference this variable. Now, the way you reference this variable is not the way I showed you. For example, when you want to reference this variable, you reference the variable, then dot, see this one is region. You got to be var.aws. So the combination of this, you don't call it variable, you give it a short name, var.aws region. Now you want to reference this variable, you do var.instant type. If you want to reference this, you reference this as var.instance key pair, right? What I showed you on that demonstration is what we use in Linux when we're doing Linux, what is called programming. When we're doing the programming in Linux, that's how you reference it. But in Terraform, you use a dot. For example, this is it. You want to reference this. You want to reference this inside. You use region, then var.aws underscore region. Where is this var comes from? Is a short form for variable. Then you put a dot AWS region. The second one is, if you want to reference your instance, is var.instance type. If you want to reference this, your key pair, it will be var.instance key pair, right? For example, this is the example. I think, let me see if we have it referenced here. If I have a reference here. No, I don't have a reference here. Well, this is an example of a reference. So this is a reference to the security group, but not a variable. But you want to output this. You want to output this variable. This is, okay, this is, let me show you what this is real quick. When you want to do an output, of the value, right? That's the block. So you want to output the ID of the security group, right? Then you do this, AWS underscore security group dot VPC SSID, and you also want to, right, meaning that you want to output this AWS security group, right, dot VPC. You want an ID. After creating the security group, you want an ID of it. After creating this security group, you want an ID of it. So this long name is just this long name dot VPC dot ID. So this is it. This long name. It's long. This could be Isaac.itoro.id. Don't let this long name confuse you. It's just a combination of this resource that you defined here. Remember, resources has 3 blocks. 1, 2, 3. This is resource, which is the name that you want to call it. And this is the name, actual name of the resource. And this is the name you call it. Now, when you want to reference it, it's a combination of this dot this, which is what you see here when you want to create an output. So you're telling this, I want to see an output. Give me an ID of AWS security group dot VPC, and this is the ID that I want to see. This is what I want, and I want to see the ID of it. This is the resource that you want to see the ID. That's how you reference that. Okay.
Please, I have a question.
Yeah, go ahead.
You said something when you were explaining output variables and input variable. Now that you've come down to the security group, I've seen when you stated that the output variable can be used when you want to see an instance. I think that's what you said earlier.
See the ID of an instance.
Yeah.
Mhm.
So, and I've seen that right now when now that you're explaining on the security group. But now I'm yet to see the input variables and the local value
The
block.
local. Oh yeah, we're coming there. I think I have that somewhere. Okay, let me see. I think I have it somewhere here. Yeah, so this is our data source. Let me see if I have the output. Yeah, this is the output values, right? So the output values is when you actually want to get the output out of it. You started with saying output, right? You want to see the output. For example, we want to see that instance public IP, the IP address, and you can also want to see the private IP address as well, right? So you create a block like this, right? And this is how you create a block, right? Because this is how the description, they have the value. But you actually have to reference it to be able to. Oh, no. In this case, when we run, I'll show you, we'll run this later on. When you run this, after you're running your Terraform apply, you actually see it on the screen. This will appear on the screen. It will show you the output values on the screen. These IP addresses, you see it on the screen, right? Those are output values, right? So this one is referencing. The input value and the output value is the referencing, what you input and what is coming out. When you're looking for the IDs, right? For example, when you group it like this, right? This is, let me explain this so I don't confuse you. Okay. So input variable, you also have output variable. Output variable is when you are referencing it. It's different from output values. So when you create an input variable, those are the variables that you create. And when you reference these variables, so that's what you call the output of the variables that you reference, right? And it's different from output values. Output values are, okay, I've provisioned an EC2, and I want to see the ID of that EC2, right? I want you to give me ID of the EC2. So when you do Terraform apply on the screen, you see those output. Okay, we'll run that program. I'll show you. I think I have some manifest that will show that as well. Then local values are different, right? Local values. Let me see if I have an example of a local values here. This output. Terraform apply upgrade. Yeah, I don't have it here. Yes, I think I have it in my other notes. Sorry, I have 3 different notes here, and I don't know which one it's best to use for. Okay, this configuration. Let's go down. Let's go down. I'll send you this note. This note is very comprehensive. It has mostly everything you can think about in Terraform. And by the way, I just redo this one, so it's a lot of stuff in here. So the attribute we're talking about is all here, and identifiers are all here in details. The meta arguments is here, so you can read all about that. Then we got into the provider blocks, right? So this is a block that we are right now. So it has all that information. Terraform setting block. This I did not talk about, where you use S3 bucket, right? So instead of storing your state file, right? Instead of storing your state file in the plain text in your local machine or your cloud, you can create an S3 bucket to actually store that and have step-by-step process on how to do this, how to create your S3 bucket and how to get that. And also, you have to put in a DynamoDB table, right? Configure DynamoDB to lock that state file. The reason is, okay, if sharing, because in most organizations, you have they store your data in a centralized region where you can use maybe Git or something, distributed infrastructure, where many people can go in and grab this code. Now, in a situation whereby someone goes, I'm updating my Terraform manifest, right? Someone can also go in and change that manifest. Now, the Dynamo file, the DB table, make sure that 2 people cannot get in there and change anything on the manifest at the same time. You see what happened yesterday? What happened why I couldn't run that program is because I had 2 of my state file running in the same machine. I had 2 of them running. So all I needed to do was shut down one, and I was able to use my original one to get in there. It wouldn't allow me. That's what it did for me because of the version that I used. Some version, the older version of Terraform, you need to explicitly put a DynamoDB is there. In the newer version of Terraform, it has that automatically, especially when you're using Terraform Cloud. It has that two people cannot create a manifest file or make changes at the same time, right? And you can explicitly, if you're running in an organization, they will ask you to put a DynamoDB. It's a good practice to put a DynamoDB in there, not relying on the one that Terraform has as the default one, right? So this is how to configure it. I have step-by-step process on how to do it here. So this is an S3 bucket that you create in your back end, right? When you are creating your state file, right? And this is how to run that Terraform unit and all that. This is your set. You have a question? Yeah, go ahead.
Yeah, just understanding something from what you explained above. So when you say the DynamoDB, it helps you, or it prevents your team members from writing into your Terraform or making changes into your Terraform state files concurrently.
Exactly.
Okay. Thank you.
Yeah. So that's what we call you lock it down. You lock your Terraform file down. Yeah. Okay. Let me see what else I have here.
So that S3 in this situation is like the remote backend, right?
It's the backend, yes.
Okay.
It's the backend. That's the backend that stores your state file. Okay. And I think I have a step-by-step. We might need to get back into this. I think I like this better. I think it gives you step-by-step on how to see. I have from step 1, 2, 3, how you can create this, right? Step-by-step approach on how to do this, right? So Terraform blocks, then we got into the Terraform blocks, right? Local value blocks and so on and so forth. Data resource block. Then we get into modules. I was trying to find something in here. The only thing is there's a lot of information in this slides. So I was trying to do a smaller version where you can use to teach without, because it takes time. I have like 200 slides in here. I was looking for a simplified version that I can represent this thing in diagrams like this, right? I start transitioning it here. I'm not done. I'm still working on this one so that I don't need to go through 200 slides, that I can explain it using diagrams, do a visualization of it, but I'm still working on that. So what was I looking for? The output and the input, right? That's what I was looking for, right? So this is data source block, right? That was the other thing that I wanted to show as well. But which one is this one? This is local values block, right? So a local value is a way to assign a name to an expression and use it in multiple places within a Terraform configuration. You see that it's more or less like a variable block that we look at, right? But it's a little bit different. So it's helpful for avoiding repetition and enhancing readability. Here's an example. It's more or less like a variable block, but it gets into you can get into the nitty-gritty of it. Like, for example, if you want to define the entire instance, right? You can create it as a local. Start with the locals, then you can define what you have in the instance AMI, the instance type, and the availability zone, right? Now this is an example. Now we have a resource, which is the instance that you want to create. Count, you want to create 3. Now, how do you reference this? I want that AMI, and what do I call it? Local.instance.ami, right? So you point it here. Remember, when you are referencing it, you're not using locals. It's local, but when you created the block is locals because it could be more than one resource, locals. But when you're referencing it just because you're referencing one resource out of it, it's local.instance.ami. In this case, instance.local. So instead of writing this over and over and over, you can just do this. So to me, it's more or less like using variable blocks, but I don't really see much difference other than the fact that you can reference the entire, for example, AMI. You can use entire AMI and reference it. Then you can just use local.instance.ami, local.instance.type, rather than typing this over and over. To me, is still a variable block. I can use one or the other because variable block will do the same thing as well, right? So that's how I understand it. Any question on this one? Then you also have data source block, right? Let's go back here. The visualization helps you. So this is a data source block. This is calling and referencing block. So you have data sources. If you have an external data, for example, SQL or Postgre, that you want to call, right? You want to use as part of your block, then you can use the data source block. That's what it is. And you have the models as well. We'll probably talk about models as well. So this is exactly how it is. Data, AWS AMI, we call it example. Most recent, true. These are some of the required variables that has to go in there. The honor, self, filter, how do you want to filter it? It's like you having a database, right? I know we've not really done a lot about database. I have database as a class that I want to teach in the next class session, looking at SQL, Postgre, my SQL, my SQL Server and all that. Oracle, I want to teach it as a separate. So when you get there, you see all these attributes, right, that you can use to call data, right? So that you can create to name the data and how you filter the data and how you can retrieve those data. So that is here. How do you want to filter? You have the data. Once you call the data, how do you filter it? By name, then what are the values that you want out of it, right? Then you can abstract the output here, right? Abstract the output and put the values in here, AWS data.aws ami.example, then the ID. You call out the ID that you need for your data source. Okay, so that's how data is used. For example, you want to provision a data out of, it could be what AWS has some kind of data storage. What are the data storage that AWS has? It has relational database, data server, right? It has, yeah, Louis. What are the data sources that AWS has?
S3 is data
S3 one,
yeah.
Source object. Which other one? It has a relational database as well. It has
yeah, it has
even DynamoDB is a data source as well. It has a RS, what is it called? What's my brain? Am I having Alzheimer's? I'm forgetting a lot of things these days. Is it H? Yeah, so it has a whole lot of, so you want to call AWS data sources, you can do that as well. And so that's what you use the data source block for. Then you have another one is the module, right? I told you about them.
So we have Aurora.
Aurora, yes.
Yes, and then we have talked about DynamoDB. We have talked about Amazon RDS. Yeah, we also have Amazon Redshift as well.
Yeah, yeah. The one
yes, even Amazon EFS, that
EFS file system.
Yeah. We also have Amazon Glacier.
Yeah, Glacier, yes. And which one that you have to? Oh, Glacier is the one that you have to. If you want to store something for a long time, you can use the Glacier, right? And you have a policy on how to retrieve that as well.
Yeah. That just stores data that is infrequently accessed.
Yeah. Then there's one that you have to take to, if you have a remote area, it's like you can take it as a truck and store data there, then you can transfer it. What is that one called?
The one that you can take data.
If you go to a place that doesn't have internet and all that.
I don't know.
Wait, let me see if I can. Okay, we're doing AWS on Sunday, right?
Yes.
All right, I'll remind you guys what it is. Yeah, they have a storage that you can just take. It's not connected to anything. There are remote areas, for example, you want to go to South Sudan and there's no internet and you want to collect information. AWS has something that they will ship to you, and you use it and remotely collect the data. Then you ship it back to them, and they will plug it into their distributed cloud. Like I said this morning, I don't know what happened. I'm forgetting everything, a lot of things.
That's brain freeze.
Yeah. So I don't know if I'm getting old or it's brain freeze or the way I slept last night. Right. But I'll give you guys all that information. I need to look it up. So like I said, this thing is, once you know it is stick in there, is there, you might not remember it, but you can go search for it. I know this thing exists, right? Now, what is it? What is it called? Yeah, you can Google it and the information will be given to you. But if you don't know it at all, you don't know. What you don't know, you don't know. It's called Snowball.